Okay, this is a sheet about to divide out a lot. Anyways, I will stop talking for a second. This is my third day, so if you want to try this homework, pause it, do the homework, and ta-da! I'm back. So this is a day of identicals. Let's get my sheet out here, and I will quickly give you the equation for identicals in case you don't have it there. But the basic equation for identicals is, the basic way to solve identicals is that you solve them just like normal ones, and then you divide out all the identicals. So remember that it's n factorial over a factorial, b factorial, c factorial, dot, 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 depending on how many identicals you have to divide out. The reasoning for that? Well, go look up a lesson. This is just practice. Okay, so I'm going to skip question 1. I'll go over it verbally really quickly here. So identify the indistinguishable items in each situation. The letters of the word lettuce. Indistinguishable item are the 2 T's and the 2 E's. Several copies of textbooks of grade 9 and grade 10 are lined up on a shelf. So the identical items, the indistinguishable items, are the grade 9 textbooks are indistinguishable from each other, and the grade 10 textbooks are indistinguishable from each other. Let's see if I can say that word a little better next time. At a buffet table, there are 4 pieces of cheesecake, 2 dishes of chocolate mousse, and 3 chocolate eclairs. Okay, so the indistinguishable items, the cheesecake is indistinguishable from one another, the chocolate mousse is indistinguishable from one another. This is like a tongue twister. And the chocolate eclairs are indistinguishable from one another. The digits 4, 5, 6 are used twice each to create 6-digit numbers. See, I don't know why they even gave this question. Well, I guess I don't know why I circled it. Let's not do that next time. The 4s are indistinguishable from each other, the 2 5s are indistinguishable from each other, and the 2 6s are indistinguishable from each other. I think I just did that to mess myself up. Okay, well, yeah, that was fun. Let's go to question 2. So, question 2. In how many ways can the letters of each word be arranged? Okay, so we're going to go pretty easy on you right now. 2a, the word maximum. There are 1, 2, 3, 4, 5, 6, 7 letters, so n's equal to 7 in maximum. The k is equal to 7. Oh, that's a good point. We are always going to do full perms of identicals, because if you don't, then you have to do cases, and it gets crazy. So we're going to do full permutations when there are identicals in it. Now, after I write down n and k, though, what I also have to write down is the identicals. So m, there are 3 of them. A1, x1, I1, u. Okay, so there's just 3 of them. So this is just going to be 7 factorial, and then you divide by the 3 factorial to get rid of the identical cases. And again, watch a lesson on there if you don't know what I'm talking about. Here, n, I'm not going to write k because it's always going to be the same as n. N is going to be in Canada 1, 2, 3, 4, 5, 6. 6 of those letters. There are 1 C. That's not what I'm looking for. There are 3 A's. So this is going to be 6 factorial over 3 factorial. Saskatchewan 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N's equal to 12. Okay, now there must be some extra multiples in here, extra identicals. So 1, 2, 2 S's. A, 1, 2, 3 A's. Let's hope I don't miss any here. K, nope. A, got it. T, nope. C, nope. H, nope. E, nope. That's it. Okay. So Saskatchewan is 12 factorial, and then you divide out the S's and the A's. So again, we're not dividing them out, but we are dividing because we're going to get multiple words that are exactly the same when you switch these S's and these A's, so we have to divide out those identical words. Interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N is equal to 11. What do we got now? I is equal to 2. N's equal to 2. T is equal to 2. E is equal to 2. S is nope. N I've already got. I have already got. G is just 1. Okay, so we'll do 11 factorial over 2 factorial, 2 factorial, 2 factorial, 2 factorial. And I am just hoping that I'm counting these things right, because I've got a feeling when I look back on this, I will have made some mistakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 this time. So n's equal to 13 on the word uninteresting. Oh my gosh. And what did that give us? So there's still just one u, and there's one extra n, so it's all the same as the last one. So t is going to be equal to 2, I is going to be equal to 2, there's one extra n, so n's now equal to 3, and e is still equal to 2. So this is going to be 13 factorial over 2 factorial, 2 factorial, 2 factorial, 3 factorial. Now, I know for these 2 factorials, I don't actually have to be writing 2 factorial, because you could just divide it by 2, but you should be in the habit of dividing by 2 factorial, because then when you get to a 3, you don't just say 3. So you have to divide by the thing factorial. But, I mean, when 2 factorial is the same as 2, you could just write that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in Mississauga, so that's n's equal to 11. M, there's 1. I, there is 2. S, there is 4. A, there is 2. UG, one of them. So 11 factorial over 2 factorial, 2 factorial, 4 factorial. Woo! All right, question 2 took a long time. Holy crap, 625. Question 5. A man bought 2 vanilla ice cream cones, 3 chocolate cones, 4 strawberry cones, and 1 pistachio cone for his 10 children. And how many ways can he distribute them? Okay, so distributing cones or lining up pieces of, lining up pieces of clothing, they're just like big perms. They're the big lineup. So it's a big lineup. So we line up the children, and then we figure out how many V's, so V's equal to 2, and chocolates equal to 3, and strawberries equal to 4, and pistachios equal to 1. So that gives us an n value of 10. Hopefully he got enough ice cream for all the kids. Yeah, he did. Otherwise that would be quite the battle. Anyways, so it's just lining up V's, C's, S's, and P's. So don't think about it as like actually giving these ice creams out. Just line up these letters. It'll make it way easier on you. So you have 10 factorial, and then you divide out the identicals. You don't have to divide by 1 factorial. That's ridiculous. Anya is starting out on her evening run. Her route always takes her 8 blocks east and 5 blocks north. So again, I'm not going to actually draw a big map here. I'm just going to go 8 easts and 5 norths to her grandma's apartment building. She likes to vary her past. How many different paths? So the n in this case, and that's why I do big N's and big E's and big I's and S's and T's and A's and all that sort of stuff, because little n is actually just the number. So there are 13 in total that I can arrange. So I'm going to do 13 factorial over 8 factorial, 5 factorial. 10. A developer will build 12 houses on the same side of this court if he has room for 2 models on plan A. So there A is equal to 2, B is equal to 4, 6 models on C, C is equal to 6. Is that 12 houses? Check, that's good. In how many different ways can he arrange the houses on the street? In 12 factorial over 2 factorial, 4 factorial, 6 factorial. So again, we're just thinking about arranging them as A's, B's, and C's. Forget about the fact that they're houses. I don't care. How many permutations are there of the letters of the word basketball? Okay, cool. So now we're actually going to get some restrictions here. So first of all, well, first is not restricted. N of basketball is equal to 2, 4, 6, 8, 10. N's equal to 10. We have how many B's in basketball? 2. How many A's? 2. How many K1, S1, E1, T1, L2. Okay. Now, there's no restrictions here, so for the first one, it's just going to be 10 factorial over 2 factorial, 2 factorial, 2 factorial. Now, B is probably going to kick up some restriction. Sorry, I can move that up so you aren't looking at the bottom of your screen. How many arrangements begin with K? All right, now, here's what I'm going to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Treat all letters as unique. So we're going to pretend that all of the K's and all of the L's and all the B's so these two B's, we're going to pretend that they're different letters, like B1 and B2. And then divide out identicals at the end. Now, this isn't the only way to do it. Some kids are going about it a different way, and they're getting totally correct answers, and I will give them full marks. But I would suggest that when you have restrictions, you do it like this. Okay, anyways, let's drop the K. There is one K. And then after that, I'm going to drop my 9 other letters, and then I have to divide out my identicals. 2 factorial, 2 factorial, 2 factorial. Easy enough? Now, again, C, this gets a little bit harder because it wants to start it with a B this time. I'm not going to draw all of the C's because it's going to start it with a B. Now, when I look at the B, though, there's 2 of them, like the B1 and B2. So there's 2 B's that it could start with. And then I go back to the bag, and no matter which B I put down, there are going to be 9 back in the bag. 8, 7, 6, 5, 4, 3, 2, 1. So 9 factorial if you went down all the seats, but I don't want to write them all out. So, 9 factorial times 2 over 2 factorial, 2 factorial, 2 factorial. Which technically you can cancel 2 of these out. So you can just leave it as this if you want, with those canceled out. But remember, don't cancel a 3 with a 3 factorial, because they're different things. 3 factorial is 6, but 2 factorial is 2. So you can just cancel it. A, B, C, D. All right, adjacent. 1, 2. This time I will draw them out. 1, 2, 3, 4. Sorry, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And L. And L. So I'll drop the 2 L's. We'll pretend like they are unique. So we'll pretend like this is L1 and L2 for now. So there is only going to be one of these and one of these. And then I'll divide it out. If you put them in as there could be 2 L's and then what? Wait. Oh yeah, sorry. So that's what I'm going to do. I'm going to put 1 here, 1 here, and then I'm going to times by 2 for the switch. So if you want to put in that there are 2 L's and then 1, then you wouldn't times for the switch. But I'm going to do them like normal. I'm going to put this down here. After we drop the 2 L's, there are 8 factorial. These could be in 9 places, and then I'm going to times 2 for the switch. So I'm treating them unique as the switch, or you could have put them in as 2 and 1, which also would have been timesing by 2. Anyways, 9 times 8 factorial is just 9 factorial, times by 2 for that switching. Even though the switching doesn't do anything, I'm going to divide it out at the end. So right here is where I divide out that switch, because yeah, when I switch those 2 L's, I get the same letter. So, again, take that out, so you get 9 factorial over 2 factorial, 2 factorial. So there will be more of those identicals with restrictions, but that's how I want you to do them. Treat all the letters as unique, do it exactly like we did it before, and then divide it out at the end. Good for that? Okay, I think that might be the last video that I do. It is, it's 8:15 on a Thursday night. I'm in my portable doing videos. Don't say I never did anything for you.